This is lesson 2-5 on solving equations using addition and subtraction. For today's lesson, you will need a sharpened pencil and your notes packet. In your notes packet, work the following 3 problems and come on back to compare your answers, and we'll continue with the lesson. The first question asks us to state whether the equation is true, false, or an open sentence. Because I see that there is the variable c in this expression or equation, I know that this is an open sentence. The next one, state whether the equation is true, false, or an open sentence. Because I see that there is no variable, I know that it is not an open sentence. That leaves me with solving each side of the equation and to figure out if they actually equal the same amount. And in this case, I have a mistake here, I see. -2 plus 5, you should have gotten 3 times 7 is 21. Does 21 equal -70? The answer is no, it doesn't. So that would be false. The last question of our study guide is about a farmer who sees his cows have gotten out of the barn. He sees 56 of his cows out of the barn. He knows that he has 83 cows altogether. Let's see, represent the number of cows still in the barn. Are there 33 cows still in the barn? Well, the first thing you should do is read this question or read the word problem at least twice. Since you've already worked the problem, that means you've already read it a couple times, so we're going to spare you that time. Are there 33 cows? We're going to save this for later and work on the rest of it first by writing an equation. I know that cows in the barn plus cows out of the barn need to equal 83. So 56 plus C equals 83 is an equation to represent that equation or that scenario. Then when I come to this, are there 33 cows still in the barn? It's asking me if 33 is a solution for the equation. Is C equal to 33? So I'm going to substitute 33 in for C and solve. And I get 89 does not equal 83, so no, there are not 33 cows still in the barn. Today's learning target is to be able to solve one-step equations using subtracting and adding. I like to think of solving an equation like keeping a barbell balanced. For those of you who lift weights, you know what it feels like to have one side of the weight heavier than the other. Just like a barbell needs to be balanced with equal weight on both the left and the right side, an equation also is considered balanced if it has the same value on the left and on the right. If you add weight to or subtract weight from one side of the bar, you must do the same thing on the other side. For example, if I had 2x here equals 10 on the other side, and let's try a different example. Let's say that I had x plus 5 on this side, and this side equals 10, and I had a balanced equation and a balanced barbell. If I remove 5 from this side and remove 5 from the other side of the barbell, what I'm left with is x equals 5. I still have a balanced equation. In the same way that I removed one of the barbells here and one of the barbells here, I'm left with one barbell and one barbell, and so it's still balanced, or one weight and one weight, so we still have a balanced barbell. Let's have this make more sense. Starting off with, what is an inverse operation? Write this down. When you undo the operation to get the variable alone is called an inverse operation. I want you to think of an opposite operation. The inverse operation of adding is subtracting. The inverse operation of subtracting is adding. The inverse or opposite operation of multiplying is dividing, and the inverse operation of dividing is multiplying. Pause the video if you need more time to write down these notes. Okay, let's put this to practice. X plus 6 equals 4. Now, I want to keep both sides balanced. You're not just learning how to find the value of x. You're also learning how to properly notate solving equations, because we're not going to limit ourselves to one-step equations. That's just where we're starting. We're going to grow and advance into having multi-step equations. So we're going to set a foundation of how we're going to notate that, starting with the easiest problems. So even if it's easy and even if you know the answer in your head, I still want you to show all of this work. Step 1, you put a line down the equal sign. Then, the reason that you put a line down the equal sign is so you can visually see that what you do to the left side, you must do to the right side of that line, because that line is where your equal sign goes, always. Next, find your variable. That's the side you're going to work with. Start with the side containing the variable. Now, in this case, it's the left side. It won't always be the left side. Now, ask yourself, what is the inverse of adding 6? Well, the inverse of addition is subtracting. So below it, I want you to write minus 6, remembering that whatever you do to one side, you must do immediately to the other side. So, use inverse operations to isolate the variable. That means to get the variable alone. Now notice that I drew this bar right here. That bar means the same thing as when I go 2 plus 3 equals 5. This bar is like an equal sign. That's the same thing with this bar that I wrote. So make sure you're writing that bar. Some kids want to just skip that. It's important that we do it all the same way. Then I go back and I say, all right, what do I have remaining on the left side? I have a positive 6 minus 6. That equals 0. Now, when we're solving equations, we're not going to write a 0 down here. We're just going to put an x through it when it equals 0 to show that it's all gone. And then I'm going to bring what remains on the left down below. And then I write my equal sign, of course, on that line. And then 4 minus 6 is negative 2. Before I'm ready to declare negative 2 my official answer, I need to check my work by substituting negative 2 back into the original variable in the original problem. Negative 2 plus 6 equals 4. So is negative 2 the solution? Negative 2 plus 6 does equal 4, and so I know that that is the right answer. So step 4 is check your work. Okay, let's do a few more problems together. Proper notation is what you're really working on now. Draw a line down the equal sign. X plus 8 equals 3. I want to get x by itself. I'm adding 8. So let's subtract 8 from both sides. X equals negative 5. Then we check our work. Negative 5 plus 8, does that equal 3? Well, I have a negative and a positive, so I subtract, and I give the sign of the bigger absolute value. So 3 equals 3. That is true, so that means negative 5 does make the equation true. Letter B, draw a line down the equal sign. This time my variable is on the right-hand side, so I'm going to start on the right. D plus 1. The inverse of adding 1 is subtracting 1. So I immediately write minus 1 on both sides of the line. 5 minus 1 is 4, and all that's remaining on the right-hand side is D. Before I'm ready to declare that my official answer, we're going to check. Let's substitute 4 in for D in the original problem. 4 plus 1 is 5 equals 5, so I know that my answer of D equals 4 is indeed the correct answer. Letter C, draw a line down your equal sign. My variable is on the left-hand side. You always want to do the inverse of the sign immediately before it. Do you see that this is a negative 4? Some people like to rewrite this as C minus 4 because you're adding a negative. You can do that. It also works to just say, okay, this is a negative 4, so I'm going to add 4. Remember, the goal is to make this equal 0. Negative 4 plus 4 equals 0. And C is all that's remaining on the left side. Negative 5 plus 4 is negative 1. Before we can declare negative 1 our official answer, we want to check our work. Negative 1 plus negative 4, does that equal negative 5? And it sure does. So negative 1 is the correct answer. Hopefully you're ready to try some of these problems on your own. Pause the video, try these 4. Then continue to compare your answers to mine. All right. Your notation should match mine as well. I'm going to do this quickly, and I'm not going to show the checking part because we don't want our video to be exceptionally long. The first thing I do is subtract 35 from both sides, and I get negative 20. All right, with this one, my variable is on the left. Now I look at the sign before it. Now, it says 89. We know 89 is positive, so we subtract 89 from both sides. This equals 0. Y is all that's remaining. So 112 minus 89 is 23. And of course, you're required to check. This next one, t plus negative 2. Again, this is one of those you could have rewritten as t minus 2 equals negative 66. That would give you the same answer. But I want to make this a 0, so I add 2 to both sides. T is all that's remaining and equals negative 64. And that's the correct answer there. All right, pause the video, try the next 4 problems, and then come on back to compare your answers. All right, here are your answers. The first one, I had to work on the right-hand side first. So I subtracted 47 from both sides and got negative 92. In the top right, I had to work on the left-hand side of this equation, and I subtracted 146 from both sides, and I got P equals negative 75. In the bottom left, negative 88 plus Z, I added 88 to both sides, and Z equals 88. In the bottom right, I added 219 to both sides, and I got H equals 43. Okay, we're going to try 2 more. Pause the video, try these 2, then come on back and compare your answers to mine. All right. With this one, I see my variable is on the right, k plus 9. So I draw a line down the equal sign, and I do the inverse of adding 9, which is subtracting 9, and I get k equals negative 28. I check my work to find out my answer is right. With this next one, this one's a little different because it is not simplified. Let's rewrite this as c minus negative 12. You could have done a super plus sign, or change it to adding the opposite. Now I'm ready to solve. C is adding 12, so we are going to subtract 12 from both sides. And I get C equals 7. When I check my work, I see that yes, that checks out. It is the solution. Now, we are not limited to always using subtraction to solving one-step equations. Sometimes you're going to have to use addition. In this example, b minus 12 equals negative 49. It's identical in process to solve, but we're going to use addition instead. The inverse of subtracting is adding, so I add 12 to both sides. This equals 0, and b remains on the left. Negative 49 plus 12 is equal to negative 37. Before I'm ready to declare this my answer, I check my work. Using substitution, negative 37 minus 12, does that equal 49? It sure does. So my answer is correct. Hopefully you saw that that was very similar to all the other ones we did. I'm going to let you do more of these independently, so pause the video and try these 3, and then come on back to compare. My voice is getting sore, so I'm going to have a water while we're doing this. Here we go. Okay, the first one, y minus 5, the inverse is adding 5 to both sides. You should have got y equals 13 and checked it. Part B, p minus 30. So I need to do the inverse of subtracting 3, which is subtracting 30. So I need to add 30 to both sides. And you get p equals 72. And of course, we checked our work. Letter C. I notice on this one, I need to work on the right-hand side where it says x minus 14. And so I need to do the inverse, which is add 14. And I get x equals 112. And I can verify that my work is correct by checking it. All right, pause the video. Try these 4. All right, hopefully this goes a little faster for you. Compare your answers. Pause the video if you need to. In some problems, you're going to be asked to do more than one step to solve. Do you see that I have some like terms here on the right-hand side? They're easier to see if we rewrite all subtraction as adding the opposite. So let's do this. P plus negative 41 plus negative 3. I can see that I have 2 constants here that I should rename or combine. Now, you cannot combine the 68 with negative 41 and negative 3 because it's on the other side of the equal sign. So you can only simplify on each side of the equal sign, not across the equal sign. So leave this 68 alone, equals P, and then plus negative 44. Now I'm ready to solve. Let's add 44 to both sides. And I get 112 equals P. And we can still check our work. 68 equals 112 minus 41 minus 3. 68 equals 68. Okay? Then this one. This is another one. That's an example of having some like terms to combine or simplify before we can start solving. Hopefully you noticed that negative 34 and 10 are like terms and can be combined. We can rename that as negative 24. Again, do not combine it with the 43 because the 43 is on the other side of the equal sign and cannot be combined. The inverse of negative 24 is positive 24. So y equals 67. And you can, of course, check that to make sure. Lastly, your friend's speakers cost $328 less than her TV. Her speakers cost $179. About how much did her TV cost? Read every word problem at least twice. Your friend's speakers cost $328 less than her TV. So let's name the variable t to represent the cost of her TV. Her speakers cost $179. About how much did her TV cost? I'm focusing mostly on this right here. $328 less than, so that's one of those that tells me that the order is reversed. $328 less than her TV, and her TV cost is, we're going to cross that off and call that T. So how do I show $328 less than T? T minus 328. And that equals the cost of the speakers. Now I have an equation I can solve. Using inverse operations, I'm going to add 328 to both sides. Then I get 7, 9, 10, carry the 1. $507 is the cost of those speakers. Okay, pause the video and try this one on your own. It's a very similar in setup. See if you can handle it and then compare your answers when you come on back. A used book costs $17 less than the same book new. The used book is $9. So a used book costs or equals. So the $9 book is $17 less than the same book new. How much is the new book? So if I use N to equal the new book cost, I'm going to cross this off and call it N. So $9 is equal to $17 less than N. $9 equals N minus 17. Isn't that $17 less than N? Then, draw your line down your equal sign. Use inverse operations to find out the cost of the book. Oops, did I say 16? I meant 26. $26. All right, give your homework